This is Unit 2, Section 2.5, describing quantitative data numerically. We started last time looking at a range, and we've talked about kind of where the centers of things are, where we've eyeballed it. Now we want to bring in that numeric or algebraic way of finding them. So this is also going to be talking about center, position, and kind of moving through some of these together. So we started kind of talking visually. Now we want to describe it numerically. So the first way that we're going to describe it is measuring our centers numerically. So the median and the mean are two ways that we can describe the center of a data point or of a data set, and the midpoint is our median, where it's 50% above and 50% of the data is below. Another way to measure the center is the mean, and this is something that we're more familiar with as far as finding the arithmetic average of the data set. And so that's where we add all the data together and then divide by how many there are, which is this formula, which is on our formula sheet. So look at your formula sheet that's in the front of your packet, and there should be this formula here, where we have a sigma that means the sum of x is our observations, I is however many iterations of those operations we have, and then observations we have, and then divided by how many in the total set, which is n. So this is provided for you, and it's written as the statistician sum of all the observations divided by the number of observations, but we've used this before. So if I wanted to find the median of each of these data sets, I'm looking for the center or the midpoint of that data set. All right, so first thing we want to do is put in order. And that's going to be from least to greatest. So if I reorder these, I would have 3, 5, 6, 7, 7, 8, 10, 10, 11, 13, 16. And so maybe you've done this before where maybe you did it this way, where you would cross them off and whatever one you would get would end up in the middle. And so you would cross them off and evenly, ta-da, 8 is going to be our median. Okay, if we did this in another way, we could, again, put these in order, 3, 5, 6, 7, and then 7, 8, 10, 11, 13, 16. And so if we did that process again, crossing off top and bottom, top, bottom, top. When we got here, if we cross these two off, we wouldn't have any other numbers left over. So what we do is we take these two numbers and we average them. So we do a mini average to find that the middle is actually our median here. That's 7.5. And on the last one, if I eliminated another value, so looking at 3, 5, 6 again, 7, 7, 10, 10, 11, 13, and 16, and this time I took out another value. So this would be 1, 2, 1, 2, 1, 2, crossing them off in pairs, 1, 2. 1, 2 would cross out everything, so we average those. 7 plus 10 divided by 2, and this is where now we get 8.5 as our median, which again is that middle 50%. 50% of our data is above 8.5, 50% of our data is below. Another way to find median is to take the number 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So if I took 11, okay, decreased it by or increased it by 1, it doesn't really matter. So added 1 and divided by 2, this would be my observation. Okay, so I would go 11 plus 1 is 12. 12 divided by 2, 1, 2, 3, 4, 5, 6. There's my observation without having to cross each one. If I have an even number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, I would divide by 2, and the fifth, 1, 2, 3, 4, 5, and 6 have to be averaged because I don't actually have that middle value there. Or if I did +1 like I did before, the 5.5, 1, 2, 3, 4, 5.5 is in the middle, which tells you to average as well. Most of us are more comfortable with the cross off, but if we had a larger data set of 20 numbers and they're not already in numerical order, we might want to bring technology into that to help us. And I'll show you how to do that at the end here. What about finding the mean? Here's an example of an AP Stats student that threw a class party and each student brought some cookies to share. The number of cookies each of the 12 students brought are listed below. So some brought 12, 12, 6, 24, 3. Who are they sharing with? 10, 9, 20, and so on. All the students combined their cookies and then split them up evenly among everyone. Here is a list of how many cookies each student brought. So how many cookies would each individual student get? So we would take the total number. So we're going to take the 144 by finding 12 plus 12 plus 8, add these all up. And I did this on my calculator and found 144. And then divided among the 12 students, and we would get 12 cookies each. So each student's going to get 12 cookies. That is a lot of cookies. And then it follows up and says another student came and brought 50 cookies to share. Okay, so now we would go back and say, okay, this total has changed because now we're going to add 50. How would the class feel about that? Okay, well, if I'm in that class, I feel like this would be like, all right, bring it on. When 50 obviously is bigger than the 12, which is our average, okay, this is going to bring the average up. Everyone gets more. So even though we're dividing now by 13, so we would take 194 divided by 13 and get our new average, we're still increasing that average here. So we've increased our sample size. We have 13 students and not 12, but because they've brought more than average already, now we're increasing that almost to 15 cookies each at 14.9. The next scenario says 2 more students came and didn't bring any cookies, but still wanted an equal share. How should the class feel about that? So now this third scenario says we have a third student, a second, and a third student that brought 0. So now we're going to be dividing by those 15 students that are now here, but we still have 194 cookies. That hasn't changed. So when we divide by 15 now, we're back to 12 cookies, almost 13. But if they didn't bring any cookies, they still want an equal share. How should the class feel about that? Well, maybe they're not happy. I mean, maybe they're still getting 13 cookies, 12 cookies. They're back to what they started with. But maybe they're not happy, especially the person that brought 50 or 28. What did I say? 24. I mean, they were told to bring cookies, they brought cookies, and now they're giving that equal share. So because 0 is less than the 12, or what did I say that one was? 15 almost. The 0 cookies brings the average down. So if somebody brought 50, hey, that's going to pull the average up. If somebody brought 0, that pulls our average back down. If somebody brought 12, it's almost like indifferent. Like everybody gets one more cookie to that group. It might bring it down a little bit lower because now we have 13 people in there. But it would be close enough that it wouldn't be affecting it as drastically as the 50 cookies or the no cookies there. And so one of the things that we're going to lead up to is this idea of resistant to outliers. So that 50 cookies, the next highest person that brought cookies was at 24. That 50 brought up the average quite considerably. And so we want to look at which center is more resistant to the outliers. So which one should we be using? because the median can tell a different story than the average, the mean. For example, in housing prices, here are the current house values in a neighborhood of 20 houses listed below in thousands of dollars. Can we find the median and the mean home values? All right, so we want to find the median and the mean. Okay, mean can be represented with something like this also, which is called X bar. And so as we start representing numerical data, we can also represent it symbolically as X bar. All right, so the median, I'm going to put these in order. Okay, so again, right now they're not in order, so I would need to put them in order and then cross out. So 1, 2, 3, 4, we have 10. So I'm looking for if 10's in the middle, I'm looking at 10 and 11. So those two houses, that would create my median. I want to average those. And then for mean, I'm going to put all of these in my calculator and divide by 20. All right, so practice that on your own. And then I have those numbers here, so pause and then come back and check to see if you got the same thing as me. All right, so I had 147 for our median, and then I had 154.15 for our mean. And so what I notice here is that my mean is much higher. Okay, that 370 that we have here, this house that's 370,000 compared to the other in the neighborhood is pulling that mean up. Okay, but the median is not really affected by that. It's only affected by it because it's another observation. It's not affected by it as far as it being a large value. The mean is affected by the value. Median is affected because it's another observation. If this was another, $3.7 million house, now this would still not change this at all, but the mean would increase even more. It would be much significantly higher. And so how do we report that? It says if a real estate office is interested in attracting more affluent families to the area, and they're listing the average home value in the neighborhood as the mean, okay? Why would they do this if they're trying to attract those affluent families? Why are they listing the home value as the mean? Okay, well, because it's higher, they're going to make potential buyers think that most homes in the area are worth more than they actually are. And so as we do that, we want to kind of consider those numbers, and they should be reporting the median. But this is where data can get kind of manipulated. Those are both valid and well found. I mean, they didn't make mistakes there, but they should be reporting the median because it's a more consistent report and it's not been affected by this outlier. Mean, affected by outlier. Median, not. Mean, not resistant. Median, resistant. So we want to kind of keep that idea because unaffected by makes more sense, but the vocabulary that AP uses is resistant. Median is resistant to an outlier. It's not influenced. Mean is not resistant. So the second measure that we want to look at is spread. We can use range, which again is not resistant, so mean it's influenced by outliers, which kind of makes sense because if we take max and min, that's where our outliers would be. And so if there's outliers, clearly the range will be affected. IQR, which is called our interquartile range, this is our middle 50%. And so 25% above and 25% below the median is kind of calculated as the middle 50%. And so that's found by taking quartile 3 and subtracting quartile 1. So how do we find this idea of quartiles? Because this might be something we haven't done in a while. Find the location of the first quartile, the second quartile, which is called the median, third quartile of the given set. So if we look at this data set, we have our minimum, and they've put this in order numerically for us. And sometimes in stats, I remember thinking like, yes, thank you, it's in order, I don't have to do that. And then we want to think about our median. So if we went 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, we'd look for our 8th observation. 1, 2, 3, 4, 5, 6, 7, 8. So this is going to be our median. Okay, and because this one is now used, we didn't have to average it. When we do our quartiles, we almost look this way and this way. So 1, 2, 3, 4, 5, 6, 7, looking for the 4th observation here. This is where quartile 1 would be. 1, 2, 3, 4, 5, 6, 7. We're looking for the 1, 2, 3, 4th. This would be quartile 3. So the range now we would be finding by taking 60 minus 5 to get us our range of 55. Quartile range, our interquartile range, is here to here. So how far away is 30 from 10? And that's 20%. So our range varies by 55, and the interquartile range is by 20. So that tells us something about our variation and the spread of the data. Okay, our 5-number summary. These are our 5 numbers. The quartiles here, minimum, quartile 1, median, quartile 3, and maximum. This is the summary that looks at, I said 5. This is the summary that looks at our data as another way of looking at it as overall a group instead of individuals. And the way that we can organize this 5-number summary visually is with the box plot. This is a graph of the 5-number summary of a set of data on a number line. So if I have these data points, they're just spread out. Even 5 to 10 is spread out the same amount as 40 to 60. So if we looked at that on a box plot, we could create this 5-number summary where we would have 5, this is our minimum, and then we had 10, this is quartile 1, we had 20, this is quartile, or the median, quartile 2, this is 30, quartile 3, and the 5th part of our 5-number summary is 60. So as we create our 5-number summary, they're still not spread out to scale. I mean, there's still kind of space. I know that one looks bigger, but it's not any scale here. So we can visually create this scale by creating something that goes from 0, and we have to go all the way to 60. So maybe I'm going to count by 10s here and try to space those out evenly and get up to 60 here. And as I create my box plot, I'm going to put a dot at 5, a line at quartile 1, a line at the median, a line at quartile 3, and another dot here, which is why sometimes this is called not box plot, but a box and whisker. And so as we create that visual where we actually have laid that down on a scale, we can see that this is potentially an outlier. That 60 seems to be much higher than the rest of the data, where 50% of the data is below 10 and 50 is above 10, but 25% is still here, where now we have 25% spread out from 30 to 60. So each of these now show us where 25% of the data is. 25% of the people here. I guess we don't know what this is. I keep saying percents or people or something. But whatever that data represents, we know that it's created that way. Breaking it up by quarters, which is why they're interquartile range, the middle quarters, 30 to 10, and so on. We can also create these on our calculator. So if I pull up our calculator here, We're going to input our data, so I'm going to go to Stat and edit that list. And so here I've put in our data, so the 5 all the way up to the 60. And before, we've done second y equals and done a histogram. So this is kind of remembering what we did last time with our other 2 plots that are off. I'm going to go back into Stat Plot 1, keep it turned on, but I'm going to change the display. Now I want it to create a box plot, and there's 2 box plots here. This one, notice it's trying to show us that it'll display outliers for us, and this one is not. I always pick this one because I want it doesn't follow any of the rules AP does to identify outliers numerically, so I want to pick one that's going to draw it out from max to min. My data's in list 1, so now I'm ready to zoom. So I go to zoom, and my favorite one is 9. So I'm in statistics class. If I'm making a stat plot, I'm going to zoom 9 to get that data here. I did not hit enter apparently, so let me try that again. I highlighted it and didn't hit enter. Here we go. I have to actually change it so that now this is highlighted, and then again do zoom 9 to get that display. And as I trace it, it might not pick the same scale as we did down here, but those numbers in the 5-number summary, minimum, quartile 1, median, quartile 3, and maximum will all match. So this is another way that we can create a display using our calculator, using technology. And the nice part is that it does put it in order for us so that we don't have to do that when we want to find the median of a larger list. So if we looked back up at those housing prices, we could have put this in a calculator and very quickly found the median and also found the mean. Let me know if you have any questions on your homework, and have a good day.